Hi everyone. In my today's topic, I'm going to explain Azure Functions. Nowadays, this particular Azure resource is being used to create serverless applications or serverless solution, I can say. Okay, so let's start with these Azure Functions. Okay, so I have not created any extensive documentation for this because MSDN or the Microsoft's documentation itself is pretty good and pretty big also. Very detailed documentation they have provided. If you want to try something or you want to go through more details, you people can go through that. So, what are these Azure functions? See, Azure Function is a serverless solution that allows you to write less code, maintain less infrastructure, and save on costs. Instead of worrying about deploying and managing servers or maintaining servers, the cloud infrastructure provides all the up to date resources needed to keep your application running. Okay, so in our traditional way of development, okay, or web development, what we do basically, we create a server side project or web API project. Okay, or it may be anything. It may be ASP.NET Core, REST API. It may be a classic ASP.NET web app. Sorry, what is that? Web forms based approach or whatever EMVC project. Okay, and then we write all our business logic. And apart from writing that business logic, we also write a lot of other cross-cutting concerns. Everything. Okay, so and then we take the responsibility of CI/CD, that is building them and deploying them, and then the maintenance. All that overhead will come on us only. But look at this, guys. With the introduction of these Azure functions, okay, our only concentration will be on writing the piece of code which serves our business purpose. That's it. That's why they are saying instead of worrying about deploying and maintaining servers, the cloud infrastructure provides all the up-to-date resources needed to keep your application running. So what I have to do, I have to simply write a piece of code, okay, which runs whenever some trigger happens. It may be HTTP request, it may be a message arriving in a queue or a topic, or it may be something else. Okay, so that's it. Just concentrate on the functionality which serves the end user's request. That's it. Okay, so what they say is you focus on the code that matters most to you. This is the very important statement. Okay, because in the modern day software development, it becomes very necessity to serve the client's need instead of worrying a lot about our technological stuffs or our infrastructure or our all technical details. Okay, so nobody cares. Hey, we are writing lots of unit tests. Okay, we are writing, we are maintaining a lot of app services or your Kubernetes pods to achieve the quality. We have ensured this level of coding standards. No, all these things matters little for the client. For the client, what they want is when they put a request, that request needs to be executed in seconds and they want results. That's it. This is how the real world business works. Okay, so that's why they say you focus on the code that matters most to you in the most productive language for you, whatever language you want to select: C Sharp, Java, JavaScript, PowerShell, Python, TypeScript, any language which is favorable to you or which is very easy for you. Just make use of that language and write your code. And that too, the code will contain only your business logic. That's it. No need to worry about other stuffs, or I can say the cross-cutting concerns. Okay, so that is one pretty thing. And this is how Azure Functions are basically providing a very structured model of serverless programming. Okay, so basically you are not required to maintain a hell lot of servers only. No need to manage the infrastructure. No need to check the health of your servers. Everything will be taken care of by your cloud, that is Azure. Just write the code which serves your purpose. Okay, so what they say, we often build systems to react to a series of critical events. Whether you are building a web API, responding to database changes, processing IoT data streams, or even managing message queues, every application needs a way to run some code as these events occur. Correct. That's what. Whenever some input comes, then only some processing will happen and we produce some output, right? So that's what. To meet this need, Azure Functions provide compute on demand in two significant ways. Okay, that's what we say, compute on demand. Whenever demand comes, then only compute. The first one is Azure Functions allow you to implement your system's logic into readily available blocks of code. These code blocks are called functions. Correct. That's what we have learned in computer science from our early days of programming. Okay, even in the programming language like C, we used to write a function which performs a specific task or which performs some function. Okay, so these code blocks are called functions. Different functions can run anytime you need to respond to critical events. Okay, so the different function can run anytime you need to just respond to those critical events. That's it. Second one is, as requests increase, here comes the scaling basically. Okay, the first one basically answers the question to how these code blocks needs to be maintained, or how these code blocks needs to be created. So for that they have introduced this Azure function. Okay, Azure functions allow you to implement your system's logic into readily available blocks of code. These code blocks are called functions. Different functions can run at any time based on the various triggers. The second stuff comes when the requests increase or decrease. That means the demand increase or decrease. Azure functions meet the demand with as many resources and function instances as necessary, but only while needed. Mark this statement: only when it is needed. As requests fall, any extra resources and application instances drop off automatically. What else you want, guys? No need to do anything manually here. Everything is done automatically for us, which is very nice thing actually. And the way they have provided an infrastructure or this particular technology, I think in the future there will be only serverless applications which will be in demand. Okay, which will be used by most of the organizations because they are fast. They don't have a heavy uplifting when it comes to the programming languages or the technology. They are very simple. Just write the code which you want or which serves the business purpose. That's it. Now, where do all the compute resources come from? Azure Functions provide as many or as few compute resources as needed to meet your application's demand. Very simple. So, providing compute resources on demand is the essence of serverless computing in Azure Functions. Agreed. That's for sure. Yeah. Now, what are the various scenarios where you can make use of Azure Functions? In many cases, a function integrates with an array of cloud services to provide feature-rich implementation. The following are a common but by no means exhaustive set of scenarios for Azure Functions. Agreed, because there may be a lot of scenarios available. Okay, but these are the most popular, I can say. Build a web API. For example, implement an endpoint for your web application using HTTP trigger. See, an Azure function can be triggered in multiple ways. That's why they provide a concept of trigger, or they provide a point called trigger. Okay, the trigger can be HTTP, it can be block storage, it can be a message queue, whatever. Okay, so one such example is build a web API, implement an endpoint for your web application using HTTP trigger. So whenever I put a request on my web browser or from the postman, that is basically a HTTP trigger, and whenever that trigger comes, execute my Azure function. That's it. Very simple. Look at the programming model, guys. Okay, no need to put Apache Tomcat server or IIS server or Kestrel server, manage them, okay, and then go through various handlers. Okay, because whenever a web request is put, it will go through various HTTP handlers and then process. It will cut off all this heavy uplifting. Very simple. Just receive HTTP trigger, okay, and do the all processing which is required for the given task. Process file uploads, again run code when a file is uploaded or changed. Okay, now then comes build a serverless workflow. Create an event driven workflow from a series of functions. Yeah, your workflow is basically a series of activities. So each activity I will represent as Azure function, and whenever an event is received, I will simply execute a series of Azure function that will complete my workflow. This is really nice, guys. Respond to database changes, run custom logic when a document is created or updated in Azure Cosmos DB. Yeah, that is also one scenario. Run scheduled tasks. Again, background jobs can be implemented using Azure functions. Really nice. Execute code on predefined time interval. Okay, this is also can be achieved over here. That is really nice. Create a reliable message queue systems. Again, whenever a message arrives into the queue, just it will trigger the Azure function and Azure Function will take the responsibility of handling that message. Very nice. And it has built-in support for queue storage, service bus, and event hubs also in Azure. Analyze IoT data streams, collect and process data from various IoT, Internet of Things devices, process data in real time. Yeah, one more scenario, use functions and signaler to respond to data in the moment. Okay, so in the previous video, I think I have explained what is signaler. Signaler is used to provide real-time updates to your application. Now, if you want to handle these real-time updates, okay, for other processes, instead of just showing some data, on your display or on or your UI, if you want to use that Azure Signaler notification to process something, simply integrate it with the Azure function. That's it. Whenever a notification or a message comes from Signaler, the Azure function will trigger and it will execute your code block. Very nice, guys. These scenarios allow you to build event-driven systems using modern architectural patterns. That's very nice. As you build your functions, you have the following options and resources available. Again, I don't go through because they have support for each and every programming language, which is very nice. Use your preferred language. Automate deployment from a tool from a tools based approach to using external pipeline. There is a myriad of deployment options available. Yes, I can create a Azure DevOps pipeline to automate this process. Very simple. And then I can release also. Okay, troubleshoot a function. Use monitoring tools and testing strategies to gain insights into your app. Flexible pricing options. Yeah, with a consumption plan, you only pay while your functions are running, while the premium and app services plans offer features for specialized needs. Very nice. Okay, so that's all about Azure Functions. Okay, again, there are a lot of other stuffs, guys. For example, if you go through their getting started, they will also give you some examples with Azure Functions, how to create it, what all tools you need, and it has support for almost all the tools like Visual Studio, the integrated development environment, my favorite. Visual Studio Code, yes, the freaks who are very fond of using Visual Studio Code, they can also, yeah, write code in Visual Studio Code, and command line also there. Anyway, that should be the basic one. Okay, so that's how you can get started. You have everything detailed instructions provided over here to start with it. Okay, and they have other concepts like the concept of durable functions. And what is a durable function? If I say durable functions is an extension of Azure Functions that lets you write stateful functions in a serverless compute environment. Okay, in a serverless compute environment, they basically provide stateful programming by using these durable functions. The extension lets you define stateful workflows by writing orchestrator functions and stateful entities by writing entity functions using the Azure Functions programming model. Behind the scenes, the extension manages state checkpoints and restarts for you, allowing you to focus on your business logic. Again, the much of the fuss and fur which is associated with these extension like the state management, checkpoints, restarts, everything is taken care by these durable functions, guys. Okay, so if you want to implement something like workflow based scenarios, then I think durable functions is your must be your choice here. Okay, supported languages, again, almost everything is there. We have to pick one and yeah, start writing program. That's it. Okay, so application patterns, they have explained a lot of, the various application patterns that Azure Functions or durable functions provide. Okay. So the primary use case for durable functions is simplifying complex stateful coordination requirements in serverless applications. The following sections describe typical application patterns that can benefit from durable functions like function chaining, fan out, fan in, async HTTP APIs, monitoring, human interaction, and aggregator. Okay, I don't want to go through each and everything, but at least we can have a high level look how it works. Pattern one, that is function chaining. When first function Azure function executes, okay, it basically triggers one more. Okay, this function 2 will be executed again. It will go in a sequence 3 4 like that. Okay, in the function chaining pattern, a sequence of functions execute in a specific order. In this pattern, the output of one function is applied to the input of another function. Yeah, so Function 1 receives some input or trigger, it processes something, and that output will be fed as input to the next function. That's what they are saying. Okay, the use of queues between each function ensure that the system stays durable and scalable, even though there is a flow of control from one function to the next. So they are making use of these queues in order to pass over the output of one function to another function. Very nice, guys. Okay, this can be used in sequential workflow scenarios. Okay, you can use durable functions to implement the function chaining pattern concisely as shown in the following example. You people can go through that. Okay, and again, fan out, fan in. I can just go through this diagram. See, function 1 executes and it puts some output, okay, into this queue, and that queue, whenever some message is entered into that queue, n number of Azure functions will be triggered again. So each and every function, Azure function will produces a different output and employs a different processing model for that input which received from the function one. And then what happens? Once all these functions completes, again all those results will be put into this message, and finally one final function will use all those outputs and produces a summary result kind of. So that is the fan out fan in pattern, it seems. Okay, so in the fan out fan in pattern, you execute multiple functions in parallel and then wait for all functions to finish. Like here, the F3 waits for that. Often some aggregation work is done on the results that are returned from all the functions. That's nice. And then pattern 3, async HTTP APIs. The async HTTP API pattern addresses the problem of coordinating the state of long running operations with external clients. A common way to implement this pattern is by having HTTP endpoint trigger the long running action, then redirect the client to a status endpoint that the client polls to learn when the operation is finished. So they have explained with a diagram. It starts over here, okay, and then it triggers some background function using this Azure function. It does the work, okay, and then it will return this result over here, okay, and then there is one more API which will get this status. Okay, that's it. And what else we have? Again, there is a monitor pattern, okay. The monitor pattern refers to a flexible recurring process in a workflow. An example is polling until specific conditions are met. You can use a regular timer trigger to address a basic scenario such as a predict cleanup job, but its interval is static and managing instance lifetime becomes complex. You can use durable functions to create flexible recurrence intervals, managing task lifetimes, and create multiple monitor process from a single orchestration. Okay. And then human interaction, again I have not used this, but anyway you people can go through the documentation. Well, that's nice. What choose the right integration and automation services in Azure. Okay, I think this is related to serverless comparison they have provided. Okay, so there are a lot of tutorial samples available, guys. I think you people can go through that, but the main idea being, I hope you people understood, Azure functions are basically used to write serverless computing applications. Okay, so with the help of Visual Studio, let me show you how to create a Azure function, guys. So I have opened Visual Studio, guys. In the Visual Studio, click on create new project or solution, and in the search bar just type Azure functions, so it will automatically list out over here. See, Azure functions. So I will select this Azure functions project template. I will click on next. Okay, now the moment I go to next screen, it asks me to provide this project a name. I will give, let's say, test Azure function. Okay, and yeah, that is the location where I would like to save it. Okay, so solution name is also same. I will click on next. Now it should ask me the various triggers basically. See, guys, okay, the moment I try to create a Azure function project, it is asking the .NET framework version, which is 6.0 long-term support. Nice. So function, okay, the function to add to this project. So what is the trigger I would like to use? See there, how many triggers I have. Empty, if you want to write your custom trigger, you can implement this. Blob trigger, used with the storage accounts, Azure storage accounts, Cosmos DB trigger, durable functions orchestration, event grid trigger. Whenever a message is put into your event grid, that time this can be used. Event hub trigger, HTTP trigger, which I'm going to show. HTTP trigger with open API specification so that you can show it in a Swagger. IoT hub trigger, Kafka output, Q trigger. So there are a lot of options. Send grid. See, even when I send a send grid email, that time also it will trigger Azure function, which is very nice. Service bus queue trigger, signaler, SQL input binding, output binding, and then the time trigger. The time trigger is mostly we use during our background job execution based on the periodic manner or daily basis. So we can make use of time trigger. So we'll take the example of HTTP trigger then. Okay. See, use Azure, right, for runtime storage account. Okay, we can use that simulator basically. So if you want to, if you want to host this application on Docker, then go with the option enable Docker. So it will add the necessary Docker file and all that stuff. So authorization level, you can select if you want to provide it as an admin, only admins can access this function, anonymous, okay, or function level. So I have selected authorization level at the function level. Okay, so click on create. So once Visual Studio creates the project successfully, I think we can see the Azure function, which is a default function created for us, and see the project file structure. Very simple, guys. They have kept the things very simple so that we can write a minimal code. Okay, so these are the various settings files. You can explore more on that. Okay, I will leave it up to you. See, you can specify the functions worker runtime. Now I'm using .NET, that's why it is .NET. But if you are going with Java or Python, the setting will be different. Okay, so that's it. And what else we have? Host.json. Okay, various other settings you can specify here, but the most important stuff being the function1.cs. Just have a look how the Visual Studio provides the default function for handling HTTP trigger. Okay, function name is the important attribute which tells this particular function, this async task of action result is your run function, is your Azure function. Okay, and inside the run function, see, can you see the parameter, the HTTP trigger? Okay, authorization level is at the function level. Okay, and I am specifying a get method here. Okay, so if I see this, yeah, I'm basically specifying the HTTP request object. Okay, so inside the run, it's the first thing, it is a HTTP trigger, and it will address get and post both. Okay, root, I have not mentioned anything. Okay, so both HTTP get and post verbs can be used for this function. So this will constitute my request, and then I have a logger. So using that, I can log the critical information. So very simple. See, from the request.query, I can get all the request query parameters. From the body, I can get the various the body sent into the HTTP request or HTTPS request. And yeah, I can do whatever processing I want to do. So let me run this and see the results. Very simple model. I think very suitable for applications which are small to medium sized. Okay, and where performance is at most priority. I think we can definitely go with this Azure functions. Even I feel for larger applications also, writing this kind of Azure functions will basically increase the application performance, and they are very responsive. So this is the best solution that Microsoft has provided, and definitely this has a future where this can become a good technology in order to implement the serverless applications. So my function is triggering now. Okay, let it trigger. So now if I go to, can you see my Azure function is up and running, and now it is telling me that boss, this is your server up and running at port 7220, and this is your function one, and it can handle get and post. Now if I go to this particular URL, I should be able to get some response. Excellent. The HTTP triggered function executed successfully. Pass a name in query string or in the request body for a personalized response. So if I pass some name, I should get greeting message, it seems. That's nice. Okay. So I have just shown a simple example of HTTP trigger, but guys, it has a wide range of scenarios and very huge support. Okay. So please explore on this and try to implement serverless applications in order to boost your application performances. Thank you for listening and have a nice day.